In this video, we're going to solve a rational inequality. We have the left side as a single expression, fraction. The right side is 0. That's what you want. Now, if you have one that has an expression on the right side, you want to bring that over to the left side, changing the sign. And sometimes you'll have to add rational expressions, find lowest common denominator, and so forth. This one is pretty much set up the way we want it. We want the left side as a single expression in simplified form, and we want the right side as 0. And then what we're going to do is going to factor the numerator. Every term in the numerator has an x. You take out the x, get x squared plus 3x. Taking out an x from that one. Taking out an x from the minus 10x gives me a minus 10. And then you continue to factor as much as you can. The expression in the parentheses there is a trinomial. We can factor that. This factors into x plus 5 and x minus 2. So I'm just going to replace this by x plus 5, x minus 2 here. Just remove this here. So the complete factorization for this then in the numerator, this would be x plus 5, x minus 2. And you can check this out that it does give you this expression here. Now the denominator is a binomial difference of squares, x squared minus 16. So that factors into the difference and the sum of the square roots. Square root of x squared is x, square root of 16 is 4, so I've got x minus 4 and x plus 4. And I'm going to use the same technique I've used used in other problems like this, the zeros method, where I find the zeros of the numerator, the zeros of the denominator, and we plot those in a number line. 2 in the bottom, so we could have 5. So let's say 1, 2, 3, 4, and 5. So you can see here, okay, x would generate 1 0 of 0. X plus 5 is 0 when x is minus 5, so that will be 0 of the numerator. And x minus 2 is 0 when x is 2. So the numerator has 3 zeros. In other words, if I plug those numbers into the numerator, the factor goes to 0, and 0 times anything is 0. Denominator, of course, you have x minus 4. That's 0 when x is 4. So the denominator has a 0 at 4. X plus 4 is 0 when x is negative 4. So we have a total of negative 4. Well, negative 4 is a 0, and we have a total of 5. And then we plot these from the number line. Keep in mind that infinity is always here on the right, and negative infinity is on the left. So we plot this in order of size. So the smallest number goes to the left, so this will be a negative 5 here. And the largest number will be over here. That will be 4. And negative 4 will be here. And we have 0 here. Then this will correspond to a 2 here. So we have 1, 2, 3, 4, 5, 6 intervals. So we look for the sign of this expression, talking about this one right here, over each of these intervals. So we simply pick a number in each interval to determine whether the sign will be a negative here or a positive. And remember here I want this expression to be less than 0 or equal to 0. So I'm looking for values where this expression is negative. So let's pick a number to the right of 4. Anything in this interval from 4 to infinity, so you have a lot of choices there. But I want to say close to 4, so let's pick 5. So pick a 5. Put a 5 where the x is. I'm going to use the factored form because all I want to know is what the sign is. Is it positive or negative? So put a 5 there. That's positive. 5x, or 5 and 5 is positive. 5 minus 2, everything's positive up there. 5 minus 4 is positive. 5 plus 4 is positive. So I'm going to have a positive over positive. So if I pick any number, and that's the beauty of this method here, all you need to test is one number in that interval. This is a plus right here. So then we go to the next one. Between 2 and 4, you can pick anything in there. You can pick a fraction. I'm going to pick 3. So let's put a 3 here where the x is. So this will be positive there. 3 and 5, that'll be positive there. 3 minus 2, that'll be positive there. Everything's positive in the numerator. And then down here in the denominator, we have 3 minus 4. That's going to be negative. 3 and 4, that's going to be positive. So a negative times a positive is a negative. Everything else on top is positive, so I basically have a positive over a negative, so I put a negative right here. And then I continue with the next interval. So between 0 and 2, I'm going to pick a 1. So let's pick a 1. Put a 1 in the numerator. We have 1 there, that'll be positive. 1 and 5, that'll be positive. 1 minus 2, this will be negative. And then down here we have 1 minus 4, that's negative. 1 and 4, that's positive. So that positive, positive, negative. So in the numerator I have a negative, and the denominator I have negative times a positive. I have a negative. Negative into a negative is a positive. So here it's going to be positive. So I pick a number between negative 4 and 0. Well, let's go, sorry, this one here. So between negative 4 and 0, you can pick anything in there. You can pick negative 1, negative 2, this one, and test it out. This should be negative. And then go to the next one between negative 5 and negative 4. I would say pick negative 4.5 and test each one like I did there. You find that this should be positive in here. So to the left of negative 5, we'll pick negative 6. So put a negative 6 here for x. This will be negative. Negative 6 and 5, this will be negative. Negative 6 minus 2, this will be negative. So I've got a negative in the numerator. Denominator, negative 6 minus 4, this will be negative. Negative 6 and 4, this will be negative. Negative times a negative is positive. Like a negative divided by a positive, this will be negative. And normally, unless you have one factor that's repeated, in other words, I have a square in one of these signs are normally going to alternate. So notice I go plus, minus, plus, minus, plus, minus. If you're not sure, then just check every interval. Now we just want the solution. We want this expression to be less than 0. That means negative. So look for the negative intervals. That one, and that one. So there's my solution. X has to be less than negative 5, has to be between negative 4 and 0, and between 2 and 4. So I'll write this in interval notation. So starting from the left side, from negative infinity to negative 5, so this will be negative infinity to negative 5. Remember, it's less than 0, negative, or 0. So does a negative 5 make it 0? Yes, so let's put a bracket here. And then we go to the next one. So this will be union here. So let's put negative 4 and 0. Now the bracket means that number is included. The parentheses means it's not. So do we want to include negative 4? Well, negative 4 makes the denominator 0. So division by 0 is not defined. So here we have to put a parenthesis. Negative 4 is not included. Everything between this negative 4 and 0 is included. Is the 0 included? Well, 0 makes the numerator 0 because I put it 0 where the x is. The numerator 0. The numerator comes 0, but not the denominator. So we want to include the value of 0. So we put a bracket in this one. And then union. And then between 2 and 4. So let's put a 2 and 4. 2 makes the numerator 0, so that's included. So I need a bracket on this one. 4 makes the denominator 0, so we don't want to include that one. So we put parentheses on this one. So this is your solution in interval notation. Negative infinity to negative 5. Negative 5 included, that's in brackets. Union. Negative 4 to 0. Negative 4 not included, so that's in parentheses. 0 is, that's in brackets. Union from 2 to 4. The 2 is included because that makes the numerator 0. We want less than or equal to 0. But we don't want the denominator to be 0. That's undefined. So on the 4 we put parentheses. That's your solution. Thanks for watching. We'll see you next time.